Factoring Polynomials with a Visual Guide. This is part 2 of a series of videos to help students understand factoring polynomials completely. In this part of the tutorial series, we will be discussing factoring trinomials of the form x²+bx+c. But before we continue, these are important concepts you might want to recall. If you need to review these topics, or you are confident enough to skip to other parts of this video, click the links in the description below. But don't worry, we'll still try to explain some previous topics naman as we go along. Factoring is so important and must be mastered by math students to be confident in understanding topics in higher math. In our previous tutorial, we have presented this visual guide to help us navigate through the complexities in factoring polynomials completely. We already discussed the very first thing to do in factoring, which is to get the greatest common monomial factor, or GCMF. After this, we can go to step 2 of the process, which is to use other techniques of factoring. Looking at this guide, there are a number of possibilities of what type of polynomials that may need further factoring. These can be classified into 3: trinomials, binomials, and polynomials with 4 or more terms. To understand further, let us show 3 exercise items from part 1 of our previous tutorial. Number 9 here, after getting the GCMF for x, leaves us with another polynomial, a trinomial that must be checked if it needs further factoring. Number 8 here, after getting the GCMF, 27x²yz, leaves us with another polynomial, a binomial that must be checked if it needs further factoring. And lastly, number 10 here, after getting the GCMF 15xy, leaves us with another polynomial, a polynomial with 4 terms that must be checked if it needs further factoring. Hence, this visual guide directs us how to navigate through this factoring jungle, if I may call it that way. Right now, we are currently here. But before we begin discussing this technique of factoring, let us show the general form of a quadratic expression, ax²+bx+c. Quadratic expressions are basically polynomials with degree equal to 2. Now, why is knowing the degree very important? It's because when we are asked to factor, and our polynomial is a trinomial, which is our topic, it usually has a degree equal to 2, and the terms are in decreasing order of degree. To illustrate, we are given a trinomial here, where the terms are arranged like in the general form above. 3x² plus 14x minus 8. Quadratic and in decreasing order, meaning the first term has a variable with exponent 2, degree is 2. The second has a variable with exponent 1, which need not be shown, thus degree is equal to 1. And the last term is constant -8, no variable, thus with degree equal to 0. It also helps to know certain math terms. The first term here is called the leading term, and a here is called the leading coefficient. In our example, the leading term is 3x², and the leading coefficient is 3. Thus, a here is 3. The second term is also called the middle term, which should include the sign. In our example, the middle term is positive 14x. Thus, b here is plus or positive 14. The last term is also called the constant term, or simply the constant, and again, should include the sign. In our example, the constant is -8. Thus, c here is -8. In this part 2 of the tutorial series, we are focusing on trinomials of the form x²+bx+c, or trinomials where the leading coefficient is 1. Of course, this numerical coefficient 1 need not be indicated anymore. Here are examples of quadratic trinomials whose leading coefficients are 1. Reviewing again our factoring visual guide, After getting the GCMF, that's step 1, step 2 branches into 3. One branch is factoring trinomials, and we are now currently here. This is the first technique of factoring trinomials, and it is of the form x²+bx+c. Let us try to figure out how we factor a trinomial with leading coefficient equal to 1 by looking at this example. We can safely assume from multiplying binomials that x² plus 2x minus 15 is a product of two binomials. We can further assume that these binomials can be the quantity x plus a certain number r times the quantity x plus another number s. That means, to get the factors of this trinomial, we should look for the values of r and s. Okay, we don't know yet how we're going to do that, but by looking at these two binomials, x plus r and x plus s, we know we can multiply them. So, recalling using the FOIL method, multiplying the first terms, x times x is x², plus multiplying the outer terms, x times s is sx, plus inner terms, r times x is rx, plus the last terms, r times s is rs. This is then equal to x², and like usual, the outer and inner terms are like terms, therefore, they can be combined. Combining their numerical coefficients, the quantity s plus r, those are the numerical coefficients, times the variable x. Or, another way of doing it, we can actually factor this group of terms. Since x is their GCMF, a topic from our previous tutorial, we can factor that out. Then, we multiply by the quantity s plus r, which is just equal to what we got by combining like terms earlier. Okay, finally, we copy the terms rs. Now, let us observe and compare the original trinomial with this product. We of course should know that they are supposed to be equal. Thus, we can look at each term. The leading term x² here is obviously equal to x² here. No surprise there. The middle term 2x here should be equal to the quantity s plus r times x. From that, we can therefore say that the quantity s plus r should be equal to 2. And finally, comparing the last terms, we can say that product rs here should be equal to the constant negative 15 here. So, let us not forget that our goal is to get the values of r and s. Looking at these two conditions, r and s should have a product equal to negative 15, and r and s should have a sum equal to 2. Now, I know some of you can easily find r and s mentally since the numbers are relatively small, but the skill we can develop as we organize and list down all factor pairs is critical for our topics for the next parts of this tutorial series. Let's try and do that. Let's get the values of r and s by looking at the second condition first. They have a product of negative 15. So, let us make an organized list of all possible factor pairs of negative 15. We know that 1 times negative 15 equals negative 15. That is one pair. We also know that 3 times negative 5 is also equal to negative 15. That's another pair. Now, can you think of other possible pairs? Okay. We missed the opposite of the pairs we already listed. We should add to our list negative 1 and 15. Learning from that, we should also list negative 3 and 5. Actually, these opposite values are often missed when listing factor pairs. Here is a tip then. When you list a factor pair, Immediately list the opposite of those numbers so you don't miss them. We are now confident that we listed all pairs. We have a total of 4 possibilities for R and S. This time, let us consider the second condition. Their sum should be equal to 2. Let's check each pair. The sum of 1 and negative 15 is negative 14. That doesn't satisfy the condition, so those are wrong values of R and S. Aww. Next pair. The sum of negative 1 and 15 is 14. Another wrong pair. Aww. Next. The sum of 3 and negative 5 is negative 2. It still doesn't sum up to 2.
Oh man!
Last chance. The sum of negative 3 and 5 is 2. Finally, we satisfy the second condition. That means that R is negative 3 and S is 5. Replacing the values of R and S here on top, the factors then are the quantity x plus negative 3 or x minus 3, they're the same, and x plus 5. But it doesn't end there. This needs checking. We do that by multiplying these binomials. And yep, you're correct. We do that by using the FOIL method. First terms, x times x is x squared. Outer terms, x times 5 is positive 5x. Inner terms, negative 3 times x is negative 3x or minus 3x. Last terms, negative 3 times 5 is negative 15 or minus 15. And yes, since their product is equal to the trinomial x squared plus 2x minus 15 here on top, we can say that x minus 3, that quantity, and the quantity x plus 5 are the factors of that trinomial. Finally, we arrive at the answer. This process might seem so overwhelming, but let's generalize to make it much simpler. Let's list the steps on how to factor trinomials with leading coefficient equal to 1. The first thing we did was list all factor pairs of negative 15. Since negative 15 is the constant c, we can say then, step 1, list all factors of the constant c. Next step we did is to find which among the listed pairs add up to 2, which is actually the numerical coefficient b of the middle term. We can say then, step 2, choose which of these factors sum up to b. Finally, step 3, check by multiplying the binomials using the FOIL method. So what's the good news in all of these? It means you can skip all these and quickly do this part only. Let's try and apply these steps to quickly solve the next examples. We are asked to factor the trinomial x squared plus 7x plus 10. By observation, this is a trinomial with leading coefficient equal to 1. Thus, we can use our technique here. Step 1. Let's list all factor pairs of c, which is equal to 10. We write here 1 and 10. And let's also immediately write their opposite, negative 1 and negative 10. 2 and 5 is another pair with negative 2 and negative 5 as their opposite. Step 1 done. Step 2. Choose which among the pairs have sum equal to b, which is 7 in this case. Let's try. 1 plus 10 is 11, not equal to 7. Negative 1 plus negative 10 is negative 11, again not equal to 7. 2 plus 5 is equal to 7. Thus, we found our pair. Our factors are then the quantity x plus 2 times the quantity x plus 5. That's how quickly we can get the answer. Final step though, just to be sure, let's check by FOIL. x times x is x squared plus x times 5 is 5x plus 2 times x is 2x plus 2 times 5 is positive 10. This is then equal to x squared. Combining the outer and inner terms, 2x plus 5x is 7x. And finally, copy plus 10. This is equal to our trinomial here. Thus, our factors x plus 2 times x plus 5 must be correct. Here's problem number 2, a more exciting example. We are asked to factor x squared minus 3x minus 18. By observation, this is a quadratic trinomial with leading coefficient equal to 1. Thus, we can use our technique here. Warning: this technique is only applicable for quadratic trinomials with leading coefficient equal to 1. Otherwise, you will get an incorrect answer. Now, let's do this. Step 1. Let's list all factor pairs of c, which is equal to negative 18. We write here 1 and negative 18. Let's also immediately write their opposite, negative 1 and positive 18. 2 and negative 9 is another pair, with negative 2 and 9 as their opposite. And there's more. 3 and negative 6 is another pair, with negative 3 and positive 6 as their opposite. If you're not sure whether you have listed all the factor pairs of 18, we can check the other numbers not yet listed. Note that we're done with 1 here. 2 is also a factor. 3 is also a factor. Knowledge in divisibility rules is important, as you can see. Now, let's check 4. It's not a factor. 5 is also not a factor. 6 is a factor, but we already listed that here. So, we just went full circle, and now we're sure we already listed all factor pairs. Nice. This method of organized listing will be used later for the other techniques of factoring. Step 1 done. Step 2. Choose which among the pairs have sum equal to b, which is negative 3 in this case. 1 plus negative 18 is negative 17, not equal to negative 3. Negative 1 plus 18 is positive 17, again not equal to negative 3. 2 plus negative 9 is negative 7, not equal to negative 3. Negative 2 plus 9 is positive 7, again not equal to negative 3. 3 plus negative 6 is negative 3. Finally, we got the pair that is equal to the numerical coefficient of our middle term. Our factors then are the quantity x plus 3 times the quantity x plus negative 6 or x minus 6. They're the same. That's how quickly we get the answer. Final step, just to be sure, let's check bifoil. X times x is x squared plus x times negative 6 is negative 6x plus 3 times x is 3x plus 3 times negative 6 is negative 18. This is equal then to x squared. Combining the outer and inner terms, negative 6x plus 3x is negative 3x. And finally, convert this to minus 18. This is equal to our trinomial here. Thus, our factors x plus 3 times x minus 6 must be correct. Before we go to some exercises, let's try to simplify some more the steps in factoring. We can actually perform these steps by simply asking ourselves the question, what are the factors of c with sum equal to b? Thus, looking at our visual guide, here at this part, we ask the same question. Let this question direct us how to factor this type of trinomials. We're now ready to answer some exercises. Since we're relatively new at this, I suggest we list all possible factor pairs first. Try them and pause this video now. Go! Here are the answers. Notice in our solution that once we got the factors that add up to the constant c, we didn't continue checking the remaining pairs anymore. It's also a good habit to always check your answer by multiplying. Do you have the same list of factor pairs? Did you get the same answers? Here are exercises 4 to 6. You can try them and pause this video now. Go! Here are the answers so you can check. Do you have the same answers? Notice that we used different variables this time. You know, just to keep you on your toes. Number 5 is different from what we have solved so far. Its terms need rearranging, descending order first, before we can use our technique. In item number 6, there are a lot of possible factor pairs. Notice that we didn't write the sum of every pair anymore. We can do that mentally instead and choose which adds up to 11. Getting better at factoring? Here's the last set of exercises. You can try them and pause this video now. Go! Here are the answers. I hope you got them all. You can go to the next video for part 3 of the tutorial series on factoring polynomials. Please don't forget to like and subscribe. Happy solving!